Good morning, biology students, and good afternoon if you're in the afternoon session. This is Ms. Benson, and I'm just going to do a quick overview of acids and bases. We'll be doing a lab on this when I return, but I just want to talk really quickly. I know you talk about this in ninth grade physical science, so this should very much be a review for you. So acids and bases, and what makes something an acid, and what makes something a base, and how are they sort of different from each other. So first of all, I think to understand acids and bases, we need to understand the water molecule and kind of what can happen with the water molecule when it splits. So this first part where I have the dissociation of water really just means the breaking up of water. So when water splits apart, it actually can form two ions. Remember, ions are charged particles. It forms a hydrogen ion, which is positively charged, and a hydroxide ion, which is negatively charged. It's an oxygen and hydrogen bonded together that collectively, we call this a polyatomic ion. Poly means many. So it's an ion that has more than one atom associated with it. So those two ions, what can happen when we put an acid in a solution is an acid can donate a hydrogen ion that also can bond with a whole water molecule to produce something called a hydronium ion. So acids, by definition, are solutions that just have a greater concentration of hydrogen ions than they do of hydroxide ions. So an acid, acids in their formula always start with a hydrogen. So this is hydrochloric acid. You can see, again, the first part of an acid is always hydrogen. And that's true of any acid formula. So when acids are combined with water, the hydrogen actually gets stripped off of that formula and then combines with a water molecule to form hydronium. Bases then, let me get rid of this because it's in the way. Bases then are different, obviously, and their formula is different. Bases, which we also call alkali, it's the same thing. They are all formulas that have an OH. Something like sodium hydroxide, NaOH, would be an example of a base formula. When bases are dissolved in water, they break apart because they dissolve really easily in water. Acids and bases both do because water is a polar molecule. Remember, we watched that little video on water. If you need to rewatch that to review, please do, because it kind of is important to understand that. So water is polar. Acid formulas are also polar, meaning they have one end. So like if we look at hydrochloric acid, hydrogen is more positive, and chlorine, but remember, by itself forms a negative ion. So the acids are also polar. So the polar water and the polar acids, water dissolves other polar molecules really, really well. So it breaks these apart like a bad breakup. Like they don't want to be together anymore. The water just pulls them apart into their separate ions. The same thing happens with bases. The water is going to pull this, the sodium off of here and pull the hydroxide off of here, and we have these separate ions. Remember, this is going to be negative. Sodium forms a positive ion, like we said all metals do. We talked about that when we talked about ions. So we get, when we dissolve a base in water, we have a higher concentration of the OH, or hydroxide ion, and that's actually what makes it, makes a solution basic. Let me get rid of this so you can see the text that I had on here before you. So I hope that helps a bit. And then, hold on just. So we use this really awesome little scale called the pH scale that kind of shows us a range of from 0 to 14 of things that are very acidic to very basic. So this scale, and students kind of, I think, or not just students, but people in general kind of always seem to want to say that the higher the number on the pH scale, the more acidic it is, which is the opposite actually. So 7 on our scale is neutral, and then the lower this number, sorry, I had something pop up, there we go. The lower this number is, the more acidic something is. So a 6 is, if something is a pH of 6, it is only slightly acidic, but as we go lower and lower, things are more acidic. So as we get down to a 1, for example, that would be something that's very, very acidic. As it turns out, this is kind of cool and fascinating, I think. Stomach acid actually has a pH of 2. So the stuff that's in your stomach has a pH of 2. And why doesn't that just eat a hole right in your stomach, burn a hole right through your stomach? Well, lucky for you, you have incredible amounts of mucus in your stomach that insulate the tissue of your stomach. It lines your whole stomach so that that acid doesn't break down the protein that makes up your stomach. So lucky you, that would be a very bad thing if you were lacking that. Things that are very basic are very alkaline. Things like drain cleaner or ammonia, window cleaners a little bit, baking soda. So if you have, interestingly enough, if you have really bad heartburn and you don't have any Tums or Rolaids, you can take a little bit of baking soda and it will neutralize some of that stomach acid. I hope this helps. Remember, you can ask me questions when I return, or email me if you need to. So good luck.